Welcome to the MS SQL Tips webcast, Troubleshooting SQL Server Connection Issues, sponsored by Idera. I'm Greg Robidoux, co-founder of MS SQL Tips and the host for today's webcast. Our speaker today is Robert Davis. Robert has many years of experience working with SQL Server, and he's also a Microsoft Certified Master in SQL Server and a Microsoft Data Platform MVP. And today, Robert will share with us what he has learned over the years to help troubleshoot connections issues when working with SQL Server. During the webcast, we encourage you to ask questions. To ask a question, enter your question in the question area in your presentation controls, and we will try to answer as many questions as possible during today's webcast. In addition to today's event, we invite you to check out all the free resources on mssqltips.com. If you're not already a member of the community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. Hey, Robert, can you go to slide 2? As mentioned, Idera is today's sponsor and also the maker of DB Power Studio. With DB Power Studio, you can quickly and easily optimize your SQL Server databases with DB Artisan, which allows you to manage performance with built-in analytics, DB Change Manager, which lets you find and track database changes, Rapid SQL, which lets you build high-performing SQL code, and DB Optimizer, which lets you tune your environment like a pro. Idera offers a free 14-day trial edition of their software, and you can visit www.idera.com after the webcast or go directly to the DB Power Studio tools using the URL listed on the screen. So at this time, I'm going to turn things over to Robert, and he can get started.
Thank you, Greg. I'm not going to bore you with a lot of details about me because, frankly, we only have an hour here, so I want to speed through this. If you download the slide deck that I've made available to Greg, and I'll probably post it on my blog as well, I've got details in the comment section of the slide. You can read tons of information about me from there, but here's just a few things about me on the slide there. I am going to be covering a lot of information, so I want to jump in quickly to troubleshooting SQL Server connection issues. Now, this man's yelling, and you can probably imagine why. It's a very confusing and convoluted topic, troubleshooting SQL Server connection issues. Everybody always wants to blame the database, and it's very difficult to distinguish when it is the database or when it's something external to the database or when it's the user, and convincing them if it's their fault. But today I'm going to talk about the common connection issues. There's a lot more we could go into than what we're going to cover today, but we only have an hour, so we're going to talk about the common ones. Server not reachable, see that one all the time. Login failure, connection timed out. These are the three things we're going to cover today. So first of all, server not reachable. One of the big issues that we run into all the time is firewall blocking. One thing people have to consider is there are firewalls everywhere. I mean, you have local firewall on both the machine you're trying to connect from and on the SQL server. Either one or both of them could be turned on and blocking. And usually people would like, well, I disabled my firewall and it's still blocking. Well, what about the firewall on the other machine? You have to check both servers to make sure they're not blocking. Check to see if they have the appropriate firewall rules added. If you need to create a firewall rule on the SQL server, then you can create a rule for the port itself on the SQL Server machine to allow traffic through the port that SQL Server listens on. And on the remote machine, you can add. It's easiest just to add a program rule on the remote machine for whatever app you're going to be using to connect to SQL Server. So, for example, if the users connect via SQL Server Management Studio, you just add an exception for SQL Server Management Studio. Yep, and make sure that if the rule exists, make sure it's unblocking the correct port. Unless you specifically set SQL Server to listen on a static port, which the default instance listens on port 1433 as a static port. But if you add like a named instance, it's going to use a dynamic port. It'll assign some port to it. And then you have to go in and so you have to go in and look at what port it's using and make sure that that port is open on the SQL Server. And also recommend, if it's using a dynamic port, to set that port to be a static port. It's very rare that the port will actually change that SQL Server uses. It typically only changes if some other program manages to grab that port before SQL Server does. But just to be sure, set it to listen on the static port so that it doesn't change and blow up your firewall rules. And make sure the rule is defined for both incoming and outgoing. An easy way to test is make just very temporarily, just to validate that it is a firewall issue, disable the firewall on both machines, test again. If it works, then that tells you that it's a firewall issue. Then you just have to figure out which one needs a rule adjusted or added to get things working and re-enable the firewall on both machines. So let's take a quick look at Windows Firewall. Now that's on the control panel. We can find Windows Firewall. Now here, and I'm on Windows 10, so if you're actually on a server, you probably won't see, you may not see this initial one. On older OSs, we wouldn't have seen this particular view. It would have immediately opened up the Windows Firewall utility, but you can do some basic things from here, like turn the firewall on or off. But what you really want to do is at this point is go to advanced settings to look at the rules. Now here I've only got firewall enabled for the private profile, not for domain. Domain is for if you're on a corporate network. I'm not on a corporate network, so I don't need a domain profile. I didn't disable public profile because I'm not a firewall expert, and I wasn't sure if that would kill my connection doing the webcast, so I just left only private profile enabled. And within that, you can see there's inbound rules. A lot of apps, especially Microsoft apps, will automatically create these firewall rules for you. So when you look in here, don't be surprised to see a ton of rules already in place. There may be SQL Server rules already set up or not. If not, you can come over, create a new role. Now for SQL Server, I'm going to say, okay, open this port. So now, and SQL Server is using TCP for the ports. So I need to look and see what ports I'm using. So in SQL Server Configuration Manager, we can see this information. Now under SQL Server Network Configuration, I've got 2 instances installed. My default instance is going to be using port 1433 because it's the default instance. So come down to IPAW, see it's using TCP port 1433. If it says if it's listed under TCP port, that's a static port. If it's dynamic, it'll be listed as TCP dynamic port. Also have a named instance, so we know that's not going to be listing on 1433. So let's look at this one. Click the IP addresses, scroll down the bottom, and actually this one isn't even running at the moment, so it's not listening on any port. So let me start this up running. So it's this one right here. Tell it to start. Now it's running, so I can come back here and see what port it's listening on. Oh. Got to enable TCP to be able to see that. Got to restart after making a change to the protocols. There we go. So now we can see what, now that we've enabled TCP, we've got the instance running, we can see it's using port 43485. Now, as I mentioned, I don't want this to change because I'm setting up a firewall wall for this port. So I'm actually going to take it out of dynamic ports and put it in a TCP port and apply it there. Now that will require a restart for that change to be picked up by SQL Server. We're not going to do anything more with that at the moment, so I'm not going to bother making you sit through that. But so now that I've got the port, I copied it from the properties. I've got TCP selected. Tell it create a rule for that port, and I'd say I can choose allow the connection, allow if it's secure. If I want to do something like enforce SSL encryption, I can choose allow the connection if it's secure, or I can just say block the connection if for some reason I want to make sure no external traffic comes into that SQL server. So I'm going to say allow the connection, and I only have the private network enabled, so I'm going to just choose private, give it a name, and now I've got a firewall rule created for that. Now I also would have to do the same thing for outbound rules. So for one of the mistakes I see made a lot with firewall when people create their own firewall rules is they're only created on inbound, and then the SQL Server traffic can't get back out to the person. So you need to set it up for inbound and outbound. Now let's say I'm on the client server and I want to create an outbound, or I'm going to create the rules for, say, SSMS to be able to connect to a server. Instead of saying a port rule, I'm going to do a program rule. Now I need to give it the path to the program, and I'm just going to look at the properties of SQL Server Management Studio here, and that has the full path here in the target on the properties. So I'm going to copy that and paste it in. Oops. Let's try that copy again. Copy, paste. Now, this has the double quotes at the end. The firewall rule doesn't like that, so I have to take those out. So I take those double quotes out, and I'm going to say allow the connection, set it for private, SSMS rule, give it a name. And now I've created a rule that allows SSMS to connect to any other server externally. That just allows on the remote machine, the client machine, SSMS to get through the firewall. And I would do the same for inbound and outbound because the traffic needs to go both ways. All right, let's come back to our slide deck. So let's talk about network firewall. A lot of corporate have their own firewall that they've set up on the network. And this isn't something a DBA is going to have access to make changes or even view it. If you think there's maybe a network firewall and that it may be causing you problems, contact your networking team. Find out if they have a network firewall and if there's any sort of rules that could be blocking it. On the network firewall, they should have a log file that logs anything that gets blocked so they can look in their log and say, oh yeah, that machine was getting blocked by the firewall. The way we've used this at companies I've worked in the past is like our production SQL servers were locked down by the network firewall based on the IP ranges of the various machines. So like it allowed like their web servers to get to it, the DBA team to get to it, the systems team to get to it, but it didn't allow developers to get to it. So we couldn't even give developers permissions to those machines if we wanted to, because without making sure that the network firewall was adjusted to allow them through. So when I commonly see this come into play, it's when you've got either when you've got like a specific subset of people who can't access it. Like say the developers can access it, but the program managers can't. Or say the developers that are in area 1 can access it, but the developers in area 2 can't. It's usually some network firewall rule breaking it down by IP range or something similar that's preventing that other group of people from getting access to it. So server not found. The types of things I'll do, like say one of our application servers is throwing out the general error, server not found or don't have access to it, which could mean thousands of things literally. One of the first things I'll do is I'll ping it from the remote server to see if it gives, does it respond to ping. Now, if it doesn't respond to ping, that doesn't automatically mean that it's an issue. You can configure a server or any machine to not respond to ping. And it's actually in enterprise environments, it's quite common to find things like SQL servers that are configured to not respond to ping. So it's not necessarily the problem if it doesn't respond to ping. But if you can respond it from ping from like your desktop, but from this other machine it doesn't respond, that's a clue that that machine's not able to reach the server. Very important thing you get from ping is, does it return the correct address? So let's take a real quick look at the ping. Some of you may or may not be familiar with this one, but it's a very common tool used for troubleshooting connections. Now just open up a command prompt and type in the name of the machine. My machine is SQL Brain 1. It's responding, so it's getting through to the machine. If I was on a corporate network, it would most likely return me the TCP version 4 IP address. This is actually returning the TCP version 6 IP address, which isn't very user friendly. There's another tool you can use to get that TCP version 4 IP address that we're all used to seeing. It's called NS lookup. So type in NS lookup space and then the name of the machine, SQL Brain 1. First, it's going to give you the name and address of the router that it connects to. So the second set of name and IP address is the target machine. So SQLbrain1.home is the fully qualified domain name, and the IP address, and this is an internal IP address, so I'm not worried about showing it to the world, is shown there. And you probably see from time to time people that connect with the IP address, but that's not working. So you can actually, if all you have is the IP address, you want to validate that's going to the right machine, you can use NSLOOKUP for that as well. If you give it the IP address 192.168.1.3, it'll return you the exact same information, so you can see, okay, yes, it's going to SQLbrain1.home here, so I know that is the right IP address for that machine. And it doesn't have to be able to reach that machine to get that information. It gets it from the routing list on the router. So even if the machine is down, you can still get that information. So let's resume back here. As I said, NSLOOKUP will return the IP address as well. And if all you have is the IP address, it'll return the name. And one of the troubleshooting things I'll do, if that passes, if it's responding to ping and it's returning the correct IP address, if it's some custom app or website or something like that that's failing, and I will try connecting to the remote server using SSMS or SQL command or PowerShell, because it could very well be something wrong with their connection string. Maybe somebody went in and was looking at it and accidentally hit a key, didn't realize it, and closed the file and without thinking, when they were prompted to save the file when they closed it, they just clicked it without thinking. Seen that happen a lot. So I want to verify outside of the app if I can connect. So if SSMS is installed or SQL command is installed, I'll use that. Or you can connect via PowerShell, or I've done in the past, I've done it with VB script. Whatever you're comfortable using and that's available on that server, just use something to verify that you can or cannot connect from that machine without the app being part of it. Because if you can and the app can't, that tells you it's something to do with the app that's wrong. Another thing to check the local host file. A lot of times people will create an alias or an entry in their host file for it to speed up the process. So let's say, like, for some reason a web server is getting a lot of timeouts because the DNS lookup of the server name is slow, and we ordered them not to use the IP address because the IP address could change. So they're, okay, I'll just put a host file entry in there, and that when it goes through the name lookup process, the first thing it checks is the local host file. It's not in local host file, then goes to DNS. So if you have a DNS problem, putting an entry in the local host file will resolve that problem, but you should only do that temporarily. A lot of times people will do that temporarily if there's a problem and then forget to take it out. And then something changes and they can't figure out why it's not picking up the change. Local host file on Windows is at the system root and system32 drivers, etc. hosts. Host is the name of the file, so the subdirectory it's in is the etc. So we can see here, and it's just a text file. It doesn't have a file extension, but you can just, click on it, open with, and choose Notepad, and it's just a text file. And I don't have any entries in my file. I haven't added anything, but if somebody had, there would be, under all these commented outlines, the pound sign is a comment. So Under this, there would be listings in the format above of IP address and name. So if you see a name in there, like if there was a name of SQL Brain 1 with a different IP address, it's going to use whatever IP address is in there and not look it up in DNS. So in that case, you would want to remove that entry and save the file. And it's on modern day servers, you're probably going to have to open it in as an administrator. So you'd probably have to run Notepad as administrator, then open the host file to be able to save changes to it. Another thing to check, client aliases. An alternative to making a host file entry is you can create an alias. This happens a lot when people don't like the names that you give SQL servers. Oh, that's too confusing. So I'm going to create a client alias that's just called prod SQL. And you can find client aliases in SQL Server Configuration Manager if that's installed. If it's not, but they do have the data access components installed, they'll have what's called a SQL Server Client Network Utility. So that's installed with the data access client, whether or not any SQL Server components are installed or not. And you can run that from the command line and its name is CLI-CONF, short for client configuration. So we look at SSMS. Now over here in the left-hand panel, we were looking before at network configuration. These are configurations for the SQL Server instances running on the server. If we look here, we see we have SQL native client configuration. We got the protocols that can be enabled. We got aliases here that can be created. So you can create an alias for the instance there. This is specific to the client. So you can't create one of these on the SQL Server and expect all the remote clients to be able to use that. If you want all your remote clients to be able to use an alias, you have to create the alias on each and every remote client. So this is specific only to where you create it. So you can just, right click on aliases and create a new alias. You give it a name, tell it what protocol, what port, server name, so on and so on. If you're on like a web server that doesn't have the configuration manager installed, you can just run here. Let's clear this off to make it easier to see. You can run a tool called run the client configuration, CLI conf. Sorry, CLI CLI-CONFG. I left the G off. So this should be on all of your servers at work that connect to SQL Server. So from here, you can set the protocols that you want enabled. So like say if you want to say enable TCP, you can do that. You can force encryption there. You can create an alias here, add here, and you can say, give it a name, tell it what type of connection you want to do. Under TCP, you give it a server name. If you need it to be for a specific port, you can uncheck dynamically determine port and type in the port there. Dynamically determined port will do just like SSMS does and try port 1433, and if that doesn't work, it'll try to get the port number from the SQL browser service. So if you don't see any aliases there, then you know that you don't have an alias causing a problem. Add that G there. come back to here. Another problem I see a lot is when the user or the client machine is in a different domain than the SQL server. So you gotta ask, does the domain trust exist? Do the two domains trust each other? There doesn't necessarily have to be a two-way trust for this to work. It is possible that you can have a one-way trust, but as long as the SQL server can authenticate to the other domain that the user is connecting from, so like if we have a domain called prod and the users are in a domain called test, and as long as prod can authenticate to the test domain, then users can connect to it using their test domain accounts. Otherwise, if it can't, then they have to use the domain account for the same domain as the machine. I will also try using the fully qualified domain name because the DNS lookup does the domain suffix in a very specific way according to how it's configured. So if the user in a different domain doesn't have the SQL Server's domain configured to be automatically appended to the name, or if there's a server with the same name in their domain as there is in the SQL Server's domain, they may be hitting the one in their local domain instead of going to the one in the SQL Server's domain. So try the fully qualified domain name. If that works, then you've either got to use the fully qualified domain name at all times or adjust your settings for that. If it's just a case of you don't have that domain suffix added to your properties, you can add it in the TCP IP version 4 properties. So let's take a quick look at that. So I'm going to come down here and say Open Network and Sharing Center. So I'm going to click on Change Adapter Setting. I'm on Wi-Fi right now, so this is the one I need to use, Wi-Fi. I'm going to say Properties. Now this is going to open a bunch of things, and as I said, we need to set this in TCP IPv4, or if that's so, click on that, click Properties, click Advanced, and then go to DNS. Here in the DNS tab, we have a lot of things that tells it. At a corporate network, you're probably going to have specific DNS servers listed here to look to use, and you're probably going to have a setting saying append these DNS suffixes in order. So it's going to say, so when you use just a machine name, it's going to look in each of these in a specific order to see if there's a match. So if you say like prod SQL Server, if that's the machine name, it's going to try this one first, and then this one, and then lastly this one. If it doesn't find it in one of these, then it's going to fail to connect. So let's say that the SQL Server is in a domain called prodsql.com. So I'm going to add here prodsql.com as a domain suffix, and it's going to be added to the end of the list. So if the issue was only that it needed wasn't in the domain suffix list, if it works when you try the fully qualified domain name, add it here, and it will then do that in the fourth. If it's trying to connect to the wrong server because there's one in one of these other domains by the same name, you can change the order by clicking these, highlight it and click the arrows here. So he's there, try prodsql.com before the home domain. So that when the when the machine exists in more than one domain, it'll connect to the prod SQL one first before it connects to the one in the home domain. And then click OK, and I'm actually going to click cancel because I don't have a domain name prodsql.com. And then, click OK all the way out of that, and that should resolve that issue for you. Another reason why, one of the big reasons I added the domain suffix in the past instead of just using the fully qualified domain name all the time is that SQL Server replication requires the machine name to be used for replication. So if you can connect via the fully qualified domain name, some of the replication tools won't work for you. So like if you open up the replication monitor, it's going to throw an error saying you have to use the machine name. So in those cases, like with replication, you absolutely have to add the domain suffix to avoid using the fully qualified domain name. Before I realized that I could even do this, I used to remote desktop into the SQL Server so that I could connect to the SQL Server locally, and not have to use the fully qualified domain name. And then one of my good friends that I worked with explained to me all about DNS suffixes, and really saved me a lot of trouble. How about a named instance? A lot of times people will have failures because they're connecting to a named instance and they're not doing it correctly, or it's not set up for it. So the first thing I do is I check, is it running on port 1433? If they're just specifying, server name / instance and is not connecting, I want to know. The reason I want to know if it's on port 1433 is because you don't need to have SQL browser running or even specify the instance name if it's on port 1433. Even a named instance, if it's on listening on port 1433, will connect. You can connect to it as just machine name, because it will. If you do just machine name, it'll connect to whatever instance is listening on that port. So I check to see, do I need to do the extra steps to connect to a named instance? If it's not listening on port 1433, check to see, is the SQL browser service running? So if it can connect to port 1433, it will then query the SQL browser service saying, hey, I want to connect to this named instance. What is its port number? SQL browser will spot with whatever port it listens on, and then it can connect. So if you're just connecting as machine name / instance name, you need the SQL browser service running so that it can connect. Alternatively, if the SQL browser service isn't running, you can provide the port number in the connection yourself, and and you won't have to be able to look it up on SQL browser. So I know a lot of places that will do that. Well, they'll leave SQL browser disabled and require that you provide the port number yourself. So in that case, you need to specify machine name / instance name, comma, port number. And this is one, I admit I've made this mistake myself and seen a lot of other people make it, is, did you use / and not /? It's machine name / instance name, not /. So if you use the wrong /, it won't be able to, it'll think that the whole thing is just the machine name. The protocols that the client and the server have in common are very important as well. The remote client must have either TCP, IP, or named pipes, or both enabled. And then the server must have at least one matching protocol. So use SQL Server Configuration Manager on the server to see what protocols are enabled on the server. And you can use Configuration Manager or the client config utility on the client, either one. And I showed you where you could see those earlier, so we won't bother looking at those again. But there has to be at least one of those in common. It can be, so they can both have TCP, they can both have named pipes, but there has to be at least one of those in common. Now, when you get that very common error, you'll see that it'll say either TCP failed or named pipes failed. So let's do a quick connection here. I'm going to connect to database engine, and I'm going to force it to use TCP. Now, because I'm on the same server as the machine, I'll either connect using shared memory, which is the default, or I have to specify which protocol to use. So I'm going to say use TCP, and it's going to take it a half a minute to error out, but you'll see in there it'll say that the TCP errored. Now, if I was connecting remotely and I have both TCP and named pipes enabled, the error is only going to report one of those, but it's going to try all protocols that you have enabled. So if both TCP, IP, and named pipes are enabled at the client, both protocols will be attempted before returning an error. And it'll try them in the order specified in client protocols, and the error will only mention the last one tried. I see a lot of questions on the forum about this is failing with TCP. Why is it failing with TCP? It's like it's actually trying both, and TCP is the second one that it tries, and so that's the one it reports in the error. It only returns the last failure, and that should be failed by now. So if we were to, when we're reading this, we can see it says provider, TCP provider. Now, for all those people out there that when they get one of these errors, send you a screenshot of their entire screen, you can tell them right here is a little button called copy message text. Click that, and we can view the text. And they can provide you with the actual text that's shown in the dialog. And if we come over here, we see it says provider, TCP provider. So the common thing I get is, why is TCP failing? Actually, both of them are failing if they're both configured on the client. And let's take a quick look at SQL Server Configuration Manager. And we see in here, for client protocols, the shared memory TCP IP named pipes. So if I connected to a remote SQL server, and it would try TCP first and then named pipes, and if it failed, the error would say named pipes. If I wanted to try it, if I for some reason wanted it to try a different error, I could right click on one of them and say order, and here I have TCP and named pipes, and I can't change the order of shared memory. It'll always try that first, so I can only control the order of additional protocols, typically just TCP and named pipes. So if I want named pipes tried first, I just change the order and click apply or OK. And you see now the order number here has changed different. Now named pipes is 2 and TCP is 3. And if it failed now, it would try named pipes, then TCP, and then the error would say that the protocol that failed was TCP. So don't be fooled by it only mentioning one of the protocols in the error. it actually tries all configured protocols, and it reports only the last one it tried. So it actually it indicates that all attempts failed. So let's move to login failure. This is one of those error codes that all DBAs end up memorizing at some point in their career. 18456. These errors, unless some crazy person has disabled logging of failed connections, never do that. All login failures will be logged in the SQL log. The real reason is often not returned to the client because that would make it too easy for someone trying to hack into the SQL server. So for security reasons, you need to look in the SQL Server log to get the real error. Now, the severity of in the error message is very important in troubleshooting why it failed. Aaron Bertrand maintains a list of known causes, and it's a very long list, so we're definitely not going to go through those. But once you look at that error in the log, read the message, see what the severity code is. Go find this blog post on Aaron's site, and then look up the severity code. I just happen to have it up right here, and you can see I'm sorry, not severity, state. So severity for state 1, and it gives you a good description of all the various reasons and things and advice on how to fix for these different states. And as you can see, it's a really long list. In fact, you could probably do almost an hour on just this error message alone. So that's the very quick way to troubleshoot that specific error. Now let's talk about connection timeout. When connections are timing out at the SQL Server, it's usually due to some resource contention. It could be CPU is at or near 100%. Creating a connection object uses CPU. So if CPU is completely maxed out, you could get failures. There is a connection limit in SQL Server. So if you hit that connection limit, and that doesn't happen very often. And where I work at, we do massive parallel operations, and we have queries running in batches of hundreds or thousands at a time. We actually do hit this connection limit quite regularly. You can check the connection, how many connections you have connected by querying sys.dm exec connections, and I'll show you a query just a little bit to see that. The connection ID in the connection tracking is a small int. So that's where the number of max connections come from. The maximum number in small int is 32,767. So that's your connection limit. After that, it can't allocate a new connection ID. More often than hitting the connection limit hit, you'll see worker thread exhaustion. This is really more common with database mirroring or availability groups because the mirroring process and the availability group process uses quite a few threads of their own. So if you have a lot of databases mirrored or a lot of databases in availability groups, you can really that can really use up a lot of your worker threads, and you can start having queries waiting for thread pull waits, or queries failing, connections failing because there were no more worker threads to assign a connection to. If for some reason you find yourself running out of worker threads, but everything else is really low, like CPU is low, memory usage is low, network usage is low, you may be able to I would only do this temporarily, but you may be able to increase the number of worker threads from the default, and that can help you get over the immediate problem till you can get a machine able to handle a bigger load. So really, worker threads is very dependent on the number of CPUs you have. And so if you're constantly hitting worker thread exhaustion, you need more CPUs ultimately. But increasing worker threads can be a temporary stopgap fix until you can get more CPUs or get a bigger machine. And of course, memory pressure. A connection object uses memory. So if the server is under extreme memory pressure, you can get an error that the connection object couldn't be created due to memory pressure. And so the connection will probably may time out, and you'll see in the SQL log an error saying that the connection couldn't be created because of memory pressure. So if you're hitting that, first thing I would do is to check all your memory settings, make sure that everything's set correctly, make sure that you're not being forcing SQL Server to page out by something external taking up all the memory, and if need be, add more RAM to the server. And I have some queries listed here that you can use, and I also have them in a separate file that I made available to Greg to post with the recording, and I'll also post this on my blog. The first query gives you the connection count. The next two queries shows you the number of threads that are spun up. For the first one is the threads per CPU to give you a list of all the CPUs and tell you how many threads are running on them. The last one is by NUMA node, and it'll show you how many threads are running on each NUMA node. And I can show you that very quick. Starting to run out of time, so I'm going to be quick, but if I run those, it'll give me, you can see here, give you the CPU by ID and a zero based, and it'll tell you how many threads have been spun up on that CPU, and then the second one is by NUMA node. 64 is the dedicated admin connection, so the other NUMA nodes will have a lower number than that. So I have one NUMA node in this laptop, so that I have 78 threads spun up on that. And that will help you determine where you are at as opposed to the total number of threads. Connection timeouts used to be logged in the SQL log. I'm not sure exactly when it changed, but at some point they stopped logging it in the SQL log and started logging it in the ring buffer instead. If it's not logged in the SQL log or the ring buffer, that means the connection attempt never reached SQL Server. So if that's the case, see the section we covered previously about server not reachable. Query sysdmos ring buffers, where ring buffer type is ring buffer connectivity, to see what's in the ring buffer about connections. I have a query. I'll show you that real quick. I provided it to Greg. I'll post it on my blog. You can also download it from my Pastebin page. Got it uploaded there. So the query is this one. So things are stored in the OS ring buffers in XML. So I want to tell it, this is ring buffer connectivity is the type of ring buffer I'm interested in. And I'm going to cast the record as XML, and then I'm going to parse that XML. You don't have to do that because I've already parsed out all the important information for you. And I tell it, give me back anything that with a record type is error or login timers. Login timers are things that didn't necessarily fail, but they just logged the time it took. So if I run this locally in my laptop, there's not a lot of very interesting information laptop in the ring buffer, I've got 3 errors. And if we scroll all the way over, we see the login is from an untrusted domain, and we can expand that out and read the whole error. So this was when I was fooling around earlier, trying to create a bunch of login failure messages that caused those. Since I don't have interesting information to show you, I grabbed this information from an actual production server, and these IP addresses are all internal, so I don't care if you see those. But I grabbed some information from real production servers to show you exactly what you might see on some of your servers. And so on here, none of these are actually errors. These are all just login timers. Tells you when it happened, what the error code is, the state, which session ID it was that experienced this, what host it was. You can use NSLOOKUP to figure out what the machine name that was. This is just your local machine IP address. Tells you what port the remote machine used. Total time is the total length of time it took to log in, and these are in microseconds, I believe. So these numbers look much bigger than what they actually are. But you can see, you can order these results if you want to by total time to find the ones that are the biggest ones. And then it breaks down the total time into various different set parts of the connection process. In queue time is if you got multiple logins, a bunch of logins all hitting at the server at the same time, and it can't process them all at the same time. It can be queued for processing. So like this one was in queued for 6 microseconds before it actually began its login process. Net writes time is how long it spent writing to the network. Net reads time. SSL total time is the time it meant performing SSL stuff. SSPI is the time it spent doing SSPI stuff. Trigger and resource governor time. So if you've got a really awful resource governor function that takes a long time, you'll see that pop up here. And then it's got just the generic text of it over here. And these values get plugged in from these columns over here. So it helps you figure out, okay, are the connections waiting a long time to be processed? Is it having a hard time writing out to the network, reading from the network? Is encryption taking a long time? Is authentication taking a long time? Is the resource governor taking a long time? It helps you narrow down exactly what part of the connection process is causing the problem. And we're almost done here. Here we are at the end. I want to thank you for attending and ask Greg if there are any questions that have come across yet.
Okay. Thanks, Robert. We should have a couple questions. So one question somebody asked is about the firewalls that you talked about earlier. They're just wondering, is it a best practice to enable the local firewall, number one, and then secondly, is there any performance hit if you have the local firewall enabled?
So the best practice really depends on how your corporate network is set up. If your SQL servers are not exposed to the internet and you have a corporate firewall in place, then there's no reason to run the local firewall on the server necessarily. And your InfoSec, that's really a question for your InfoSec team, what they want you to do. Now there is the possibility that maybe somebody will find a USB drive in their machine in the parking lot and think, "Ooh, I wonder what's on here," and they put it into their machine. And if they have access to the SQL Server, then stuff will get on it. But it's that's if they have access to SQL Server, then that firewall could prevent that, because whatever like malware they loaded up from that USB drive may or may not try the specific port. If it finds a machine, more than likely it's going to scan looking for open ports. And so as long as any port is open to that person, more than likely it's going to find any malware is going to find it. But there is a very, very slim case where it could prevent something from getting through. But really, it's a question you need to ask your InfoSec team. Now, on like a laptop, if you use a laptop at work, even though it's on a corporate network, I recommend still having the firewall running. If you're like me and you run SQL Server locally on your laptop, I mean, you're going to take that laptop to other places where it's not on the corporate firewall. So you're not going to want to keep turning it off and on. So in those cases, I would definitely have it running on your laptops.
Okay.
And you shouldn't really notice a performance difference from having it running. It'll either not work at all or it'll work just fine.
All right, great. All right, that's about it. So we're just going to wrap things up. So thanks a lot, Robert, for sharing that information today. And to all of our listeners out there, don't forget to visit Idera's website at www.idera.com to learn more about DB Power Studio and to also download your free trial edition of the software. The webcast was recorded, and you'll receive a follow-up email with links to view the archive. We'll also get a copy of the slides posted that you can download, as well as all the scripts that Robert shared today. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.